So carrying on from last lesson where we learned how to solve differential equations using a method what we called separation of variables. Yeah, separating egg white and the egg yolk. Yep. So now differential equation can be used in more real life situation. You've learned how to construct them, which is chapter 9.10. Remember the stuff where you talk about find the rate of something, find the rate of something, and then proportional or something. You have to construct a dp by dt equals pt, that kind of stuff. Yep, so you've learned how to construct them, and then you've also learned how to solve them from last lesson where you learn how to solve them using separation variables. This lesson you're going to look at just differential equation, but with modeling question in there. So essentially the maths is the same, but they just add a different coating in there, a sugar coating in there. Okay, when sugar coating. Next one. So example: the rate of increase of population P of microorganisms T is given in hours by dp by dt equals 3p. So this one, you don't have to construct anything because they gave you already, okay? Initially, the population was of size 8. Now, when you come modeling, you have to understand these kind of wordings are what we call the boundary condition that can help you to find the particular solution, okay, from last lesson. So this is when t equals 0, p equals 8. So something to remember of. Now, to use this, what we need to do is we need to make a dp by dt equation into just p. So dp by dt equals 3p. Now, this is what we need to do, separate variables, okay? Now, when you think about what you need to move to the left and what you want to move to the right. So, like last lesson, we know the dp has to stay on the left-hand side, okay? Now, you've got two options. You can either move the 3p altogether left-hand side or just move the p. Now, personally, I would just move the p over, okay? I'll show you, the reason is if you just move the p over, then the 3 remains an integer. But if you move the 3 over the left-hand side, it becomes 1/3, which is not a big deal. But personally, if you can keep it like a whole number, then you can keep a whole number. So that's what I'm going to do, okay? So p has to divide left-hand side, and dt will have to multiply right-hand side. Okay, so that has to divide, oops. So we know that has to divide, and this has to times. The next step becomes 1 over p dp equal 3 dt. It looks a bit bold at the moment, so we're going to put an integral sign, put a hat on there, okay? So then you can see then we've got two integral on the left and right. We just integrate left side, which is NP. On the right side, it's just 3t. Don't forget the child plus c. So some of you might be asking, why do we not put a plus c on the left side? Why do we need a plus c on the right side? The reason being is c is just a constant. If you put c on both sides, it's like, for example, in the equation, you have x plus 4 equals 2x plus 2. What do you do with these two constants? You're going to merge them together, give them -2 plus 4 minus 4 on the right side becomes a -2. So ultimately, that you just have a one constant. So yes, you have two constants to begin with, but when you merge them together, you only have one constant. So we usually just leave with one constant just for, easier of things. We don't need two constants in there. So so plus c. Next, when we make p the subject, so we're going to e on both sides. E to the power of NP equals e to the power of 3t plus c. And then we can make e and then cancel out. P equals e to the power of 3t times e to the power of c. You've learned this trick. And then you can let e to the power of c equals a. Let a equals e to the power of c. Oops, I can't write. Right, can't write. Let's try again. We can let a equals e to the power of c. Therefore, p equals a e to the power of 3t. Okay, but when you find the value of a, and that's when we have to use the boundary condition, when t is 0, p equals 8. So substitute in there. So 8 equals a e to the power of 0. A to the power of 0 is not 0. A to the power of 0 is 1. Okay, so e to the power of 0 is 1. So it's 1a. So a equals 8. Therefore, we're going to rewrite nicely. P equals 8e to the power of 3t. And that's the answer for A. Okay, part B. Find to nearest 100 the population when time equals t. So they told you what to do when t equals 2. Okay, so when t equals 2, then p equals 8e to the power of 3 times 2, which is put in the calculator, and you get 3,227. The one at nearest 100, so that's 3,200. Simple as. Right. Part C. Find the time at which the population will be 1,000 times of its starting value. Now the question is, okay, what are they trying to get you to? There are two variables in this question, P and T. They want you to find a time, okay? Then surely P has to be known. Well, indeed, you do know. They say 1,000 times the starting value. The starting value is 8. That means 1,000 times of 8 is 8,000. That means when P equals 8,000, that's where they're trying to get you to. Okay, so part C, when P equals 8,000. So solve it. So 8,000 equals 8 e to the power 3t divided 8 over, and then so e to the power 3t equals 1,000. ln on both sides. Put it here, ln on both sides, ln e to the power 3t equals ln 1,000. So t equals ln 1,000 over 3. Put in a calculator, that's 2.30 hours. If we put in minutes, that's 2 hours and 18 minutes. Now, some of you still don't know how to convert the 0.3 hours into minutes. So you just do 0.3 times 60, because 1 hour is 60 minutes. So 0.3 times 60, that's 18 minutes. That's how we do it. So 2 hours, 80 minutes. This trick, you probably use it quite a lot with trigonometry modeling when they ask you about the boat. That's those are questions where state the time that the Ferris wheel passes through this, or the boat that crosses a river at a certain time, what hour, what minute, that kind of thing. So yeah, they're not that unpopular. So yeah, or uncommon. Sorry, English. Part D. Question D. Let's have a read. State one limitation to the model. Well, we know this. Think about long term. Okay, we are people with good minds. We always think about the future. Okay, we don't care what we eat tonight, but we'll think about what our child will eat. So one limitation to the model. Think about the future. So in the future, when T gets really big, okay, so is P. However, there's an issue with that because P is a population, so P cannot grow infinitely. Why can't P grow infinitely? Because they might run out of food. So that's the answer, part D. So part D, just type it out. So the microorganisms might run out of food to grow in long term. That's the answer. Okay. Yeah. That's it. Next one. Okay. Example. So water in a manufacturing plant is held in large cylindrical tank of diameter 20 meters. There's one outside knowledge. Does anyone know why does these type of water plant, whatever, it has to be in cylinder? Why is shape has to be cylinder? Why does a can has to be cylinder? Why can't it be a cube? Why can't it be like a tissue box? Why can't it be a cuboid? Why does it be a cylinder? The reason that is because the cylinder, the shape itself actually can withstand the most pressure with liquid. So that's why, a can is always in a cylinder, because they can, even if you think about beehive, it's always sort of in a hexagon, close to a circle, because they can withstand the most pressure inside and outside. And that's why. Anyway, so we're told diameter 20 meters. Water flows out of the bottom of the tank through a tap at a rate proportional to a cube root of the volume. So in here. Right, so water flows out. So that tells you negative. Okay, so flows out means negative at the bottom of the tank through a tap at a rate. This rate measures the volume over time. The volume over time. Cube root of the volume, proportional cube root of volume, that's K times cube root of V. Okay, so therefore, essentially it means dV by dt equals negative K times cube root of V. Okay. Part A, show that t minutes after the tap is open, y dx by dt equals k cube of root h for some constant k. So they want you to find dx by dt. So this is the type of question we did in 9.10 part 1 or part 2, I can't remember now, where you have to make your own equation. So pause the video, you should know how to do this, okay? But if you're struggling with it, you can play the video, carry on with the video. So you start by the function asked by the question. So asked by the question, dx by dt. If you're struggling with it, go back to chapter 9.10, part 1 of the video, of the Pure 2 module. So asked by the question equals given by the question. You're given dv by dt. Okay, you were given dv by dt, like the one we had above, times a fraction made by your own, that when you cancel off dv by dt, it gives you dx by dt. So now there's no dv on the left hand side, therefore you must cancel dv in here. There was dx on top, so that's dx. The shortcut is you put this numerator, this denominator. Okay, we've gone through this before. So I'm going to rewrite the equation as we know dv by dt is given by the question is negative k times k cube root of v times dh by dv. So what's dh by dv? Well, we need, first of all, we need an equation that links v and h together. In a volume, in a cylinder, volume equals pi r squared h. So radius is 10, so pi times 10 squared times height, so v equals 100 pi h. Then we do dv by dh, which is 100 pi. So dh by dv, flip both sides, is 1 over 100 pi. We'll put it back in. Then our equation now becomes dh by dt equals negative k times cube root of v times 1 over 100 pi. I don't like this as two fractions, so I'm going to put them together. This step looks, unnecessary, but, sometimes people just do things unnecessary, and I'm one of them. Next, read the question, compare what's different. Okay, so we've got minus k, that's good. But the cube root, we've got v, they've got an h. That means we have to change this. And we do know v is 100 pi h, so we'll sub it in there. Okay, so dh by dt equals negative k times cube root of 100 pi h over 100 pi. The question just want a cube root of h, so maybe we can split out the cube root of h. So equals negative k times root 100 pi, cube root of 100 pi over 100 pi times cube root of h. So next, now if we compare with the question, they've got a negative in front, we've got a negative as well. Okay, we've got cube root of h, we also got cube root of h. What it means is, now they only got a k, but k is a constant. So we know this is a constant. So we can let k1 equals to k times cube root of 100 pi over 100 pi. K1 is just another constant. Again, it's like simplifying some constants. You put in a calculator, you get another one. So we just let K1 to be that complicated constant. So we let K1 to be that constant, then now dH by dt equals negative K1 times cube root of h. And that's sorted and that's done. Okay. Part B. Now, in exam, if you can't do part A, don't give up. Okay, keep going with part B. Even though if you don't know what K is or whatever it is, just use that value in there. You might get some method mark, you never know. But a lot of students, if they give up, they'll be giving up a lot of marks. So don't do that. Part B, show that a general solution of this differential equation may be h equals p minus qt to the power 3 over 2, where p and q are constants. By the way, this is another separate question. Okay, that's full stop. Initially, after what initially means is for part C. So what we need to do is we need to solve differential equation. We'll learn one method to solve differential equation, which is known as separation of variables. Split the egg white and the egg yolk. And so we've got this dh by dt equals negative k cube root of h. So we'll start from there. Part B. So we know dh by dt equals negative k cube root of h. So what about K1? Doesn't matter. It's just K. Question start with K with UK. Right. Next, we need to separate them. Okay. So cube root of H will go with DH on the left hand side, and then DT and the minus K will stay on the right hand side. Okay. Anything with the H will put left. Anything without H will leave on the right. Remember, you can only times and divide. So we divide the cube root of h over, so it becomes 1 over cube root of h dh equals multiply dt over negative k times dt. So integral on both sides. Left hand side, I will give you time to think about, okay, how do integrate on both sides? So pause the video now, have a think about what would you write the next step. When you're ready for the answer, press play. Right, left hand side is h to the power of negative a third. So to integrate h to the power of negative a third, that's h to the power of negative a third. To integrate, simply add 1 to the power, so h to the power of 2/3 divided by new power 3 over 2 equals, to integrate minus k dt, minus k is a constant. So imagine you're integrating minus 5, you'll get minus 5x. So in here it'll be minus kt plus c. Okay. What we need, the question was h to be the to be a subject, so we'll do that. To make h a subject, we can multiply this 3 over 2, or we can multiply 2 over 3 at the right hand side. So h to the power of 2/3 equal minus 2 over 3 kt plus 2 over 3 c. What's next? They want h subject, so we're going to get rid of this power. To get rid of this power, we can do the reciprocal power on the right hand side. So h equal negative 2/3 of kt plus 2 over 3c to the power of 3 over 2. You don't get it. Okay, let me show you something. Let's say when we x to the power of a half equals 9. How do I do this? How do I simplify this? How do I work it out? Well, you square on both sides, don't you? So can you see when you square on both sides, essentially you're doing the reciprocal of this power. 1 over 2, the reciprocal is 2 over 1. So 81. Now, if I want to do, let's say, another one, let's say, how about x to the power of 4 over 5, 4/5 equals to, I don't know, let's say 32. Then you do the reciprocal on the other side. So you can do the power 5 first on both sides. I'll just show you. So you could do the power 5 first on both sides, and then the 5 and 5 cancel out, and then fourth root it, and then fourth root it. So 32 to the power 5, fourth root it. That's the same as 32 to the power 5 over 4. So again, you can see that becomes reciprocal. Yeah, so shortcut is, if you want to get rid of this one power on the left side, you can do reciprocal power, the whole thing, to the right side, right? That's the C. Now, compared to the question, P minus QT. Have we got P minus QT? Yeah, we do, because that's P, that's QT. So in here, we can let P equal 2 over 3C, and we let Q equal minus QT, so 2/3 of K. So that H becomes P minus QT to the power of 3 over 2. So Q is just 2 over 3K in here. There you can see, minus KT. Why do you not put a negative in there? Because there's negative in front. Therefore, if I put a negative, if I let Q to be negative, this will become plus a KT, plus a QT, a QT pi. Right, that's it, sorted. Next one. Initially, the height of the water is 27 meters. So by now, you smarties should know, what does this line here mean? Yes, it's the boundary condition. When t is 0, h is 27. What else? When 10 minutes later, the height is 8. When t equals 10, h is 8. So we can use this to find boundary conditions. Find the values of the constant p and q, so we can substitute in there to work it out. So, part C. H equal, let me rewrite that. I don't know why I need to rewrite that. It's just right above me. So when t is 0, h equals 27. Sorry, 27. So sub it in. So 27 equals p minus 0q. That's gone. 0q to the power of 3 over 2. So 27 equals p to the power of 3 over 2. Same thing, if I want to get rid of this 3 over 2 in the power, I can do the reciprocal power on the left-hand side. So 27 to the power of 2 over 3 equals p. Put in a calculator, or you can do, super quick mental math like I do. 27 to the power of third is 3. 3 squared is 9, so p equals 9. Therefore, h equals 9 minus qt to the power of 3 over 2. Next, when t equals 10, h equals 8. Sub it in. So 8 equals 9 minus q times 10 to the power of 3 over 2. So you can't multiply this in because it's a fractional power, but you can do the opposite reciprocal power on the left-hand side. So it becomes 8 to the power of 2 over 3. And then equals to 9 minus 10q. So put in a calculator or do some super quick mental maths. 2 squared 4, or 4 equals 9 minus 10q. And then you can simplify it, and you get q equals to a half. Therefore, h equals to 9 minus a half t to the power of 3 over 2. Ta-da! Part D. Okay, ready? Part D. Find the time in minutes when the water is at depth of 1 meter. So I want to find t, so you're given h. So h equals 1. Simple as, you just put in h is 1, part D, when h equals 1. So 1 equal 9 minus a half t to the power of 3 over 2. We've said this many times, to get rid of this 3 over 2, we can do reciprocal power on the left-hand side. But 1 is like the calmest person in the world. Whatever happens to him or her, it has no effect. Okay, 1 to the power of 2 or 3 is just 1. So 9 minus a half t. So bring it over, half t, bring 1 over, becomes 8. 2 equals 60 in 60 minutes. That's the answer. Okay, right. So next one, exam practice. So pause the video. Now, part A is slightly a bit weird, so we can go through together first part A. But you can, if you want to have a go at part A, you can feel free to have a go first part A. Pause the video, have a go. Whenever you're ready for part A, you can press play. So liquid is pouring into the container at a constant rate of 20 centimeters cubed per second. So a rate. So in here you can tell this is going to be dV by dt, judging by the unit is 20. It's pouring in, so it's positive. And it's leaking out. So leak out means negative at a rate proportional, dV by dt, proportional, negative K, volume of the liquid already in the volume, so minus kV. So altogether, it's 20 minus kV. But here they have to ask you to explain why is that the case. So you have to use the word to explain. I'm going to show you how. So you have to explain. So dV by dt is the rate. So you have to write in words. It's the rate of increase of the water, over time. And then you also have to explain negative kV shows the decrease of the leak. That shows the effect of the leak. Sorry, effect of the leak. And then you also have to say K is the constant of proportionality. So I should have write a bit neater. Proportionality. NALITY. Yeah. Okay. These questions, are quite rare nowadays. They probably ask you to make this out from the beginning rather than asking you to, rough it out or write out whatever. Puppy, the container is initially empty. So initially empty. Right? Initially empty. By solving the differential equation, show that V equals A plus B e to the power of negative KT, giving the values of A and B in terms of K. Right. So you can pause the video, have a go first. Okay, separate your variables. When you're ready for the answer, you can press play. If you do it correctly, your A should be 20 over K and your B should be negative 20 over K. But if you got it wrong, let's go for Y. If you got it wrong, just move on part C. Okay, so part B, we start with, we're told dV by dt equal 20 minus kV. So first question is, what has to go on the left and what stays on the right? You know, in times to divide. Now, I know it'd be tempting to add kV on both sides, but it doesn't work like that. You go in times to divide. So if you can't add the kV to left hand side, that means you have to move the whole thing to the left by dividing. So it becomes 1 over 20 minus kV dV equals, and nothing on the right, so put a 1 dt. Okay, so move the whole 20 minus kV left hand side by dividing. Okay, now how do you integrate this? Think about RTSP is a fraction, LNP. You start by, ln, you let y equals ln denominator, 20 minus kV. So dy by dv in here, differentiate it to verify it. So 1 over 20 minus kV. Differentiate ln is 1 over. Differentiate inside is negative k. So that's negative k over 20 minus kV. So compare with the original. There's no minus k in there. So we have to divide it over or multiply reciprocal. So it will be negative 1 over k of the y function ln 20 minus kV. On the right side, to integrate 1, it's just t plus c. Okay. Next, we're told initially empty. That means when t is 0, v is 0. So where did it come from? It comes from this line here. It says initially empty. So when t is 0, v is 0. So we sub it in. So when t is 0, v is 0. So minus 1 over k ln 20 minus kv minus k times 0 equals t plus c. So c equals minus 1 over k ln 20. So we substitute in the original equation. So negative 1 over k ln 20 minus kv equals t plus c is no longer c, is 1 over k, negative 1 over k ln 20. I'm going to make v the subject. That means I have to, well, I can multiply everything by negative k to get rid of the negative in front here. So if I multiply everything by minus k, then I get ln 20 minus kv equal negative kt becomes a plus ln 20. To get ln, I can e on both sides. So I get e on both sides. So e to the power of ln 20 minus kv equals e to the power of negative kt plus ln 20. Left hand side, e and ln cancel out. So I'm just left with 20 minus kv. On the right hand side, I can do a separation of the power again. So e to the power of negative kt times e to the power of ln 20. Step by step. A lot of students would have made a mistake from here. They'll put a plus in here or do something different weird. So e and ln do cancel in here. So 20 minus kv equals 20 e to the power of negative kt. To make v the subject, I can bring the minus kv right hand side and bring this left hand side. So 20 minus 20 e to the power of negative kt equals kv. That can divide everything by k. So if I put v on the left hand side again, so it'll be 20 over k minus 20 over k e to the power of negative kt. Let's compare with the question again. So v, a, that's your a, minus or plus b e to the power of negative kt, that's my e to the power of negative kt, so b has to be this one. So therefore a is 20 over k and b is negative 20 over k. That's the answer. That's the final answer. Okay. Part C. If you got part B wrong, okay, have a go at part C now. Again, given also that dv by dt equals 10 when t equals 5. Find the volume of liquid in a container at 10 seconds after the start. Now, if you try to substitute t is 10 in here, you will find yourself still the k's value is missing. And that's why you're given an extra information here to help you work out. Okay, this boundary condition. Now, if I want to use this boundary condition, you realize I can't use it quite yet. Well, why? Because this dv by dt, that's v. So you have to make this v into dv by dt so you can use this. Okay. So I'll explain again. If I want to use this boundary condition, I need to use dv by dt equation. But this is a v equation, so I need to do a differentiate again to find dv by dt. Okay, so I'll use different color for part C. Part C. Oh, dv by dt, so let's differentiate. Okay, so differentiate 20 over k is gone because the constant. Differentiate this, you multiply by the negative k, so it'll be negative 20 over k times negative k e to the power of negative kt. To differentiate anything with the power of e, you just multiply the coefficient down. Okay, so minus k is cancel out, so dv by dt equals 20 e to the power of kt. Now you're told when dv by dt equals 10, t is 5. So 10 equals 20 e to the power of k to the power of 5. So in here, when t equals 5, dv by dt equals 10, you're given that. I can divide 20 over, becomes a half, so a half equals e to the power of 5k. To find a k at ln on both sides, so ln a half equals ln e to the power of 5k. ln e cancel out, so 5k equals ln a half, divided by the 5, so k equals a fifth ln a half. It's quite ugly, yes I know, but it is what it is. So we finally got the value of k. So we can now substitute into value of v, okay, and then when t is 10. So let me rewrite that again, sorry. So v equals 20 over k, so v equals 20 over k minus 20 over k e to the power of negative kt. Now, what I suggest you do is put it in a calculator and insert in your answer button. Okay, when t is 10, we just stop in when t is 10. So whenever you see k, you just use the answer button in the calculator. So I can show you that. So so v equals 20 over. So let me put a calculator. 1/5 of ln a half. So ln a half. So that's my, okay, that's my k value. So when I see this k, I use the answer button. So v equals 20 over k answer minus 20 over answer times e to the power of negative k negative answer times 10 times t times 10. So I get v equals 432.8. So v equals 432.8. And did I make a mistake somewhere? K equals negative fifth. That's wrong from my question. Let me have a look again. So ln e to the power of, I made a mistake here. Was minus k minus, my bad. So k is negative 5k. So that's minus 5k. So that's minus, you know, that one negative messed everything up. So let me put in the calculator again. So let me put this in the calculator minus again. That'll be my answer button now. So let me try to equal, yep, 108. So my bad. So 108 centimeters cubed. And that's the final answer. But it's a difficult one, but it's not totally undoable. So that's the, you know, that's the end of all difficult stuff in integration. This will be the last part about integration, where you got one more chapter, one more bit about 11.12, but it's a standalone chapter. It's like trapezium rule. You know, it's nothing to do with the big thing, the big scheme of integration. In the large scheme of integration, you know, this type of question is what you will see in the exam, where they ask you to do modeling, do separation of variables. The hardest one could be asking you to construct your own, construct your very own differential equation to begin with. Okay, so yeah, and that's it. Thank you for listening.